It's usually easy to figure out how a criminal enters a crime scene, but in this case, it was far from clear. The killer vanished in thin air. Hi, I'm Michelangelo, and I am the host of this show. A body rushes up on shore with a gunshot wound in his head. The body was identified as Edward Hoff, a 16-year-old male who goes to Pearson High School and has been missing for over 6 weeks. As we cleared the body from the scene, we noticed that he has been dead for 2 months. The next day, we informed the parents and the school.
We can estimate that within minutes, Edward's body sinks to the bottom of the water due to water filling the lungs and all excess air being released. Since it was winter at the time of the murder, the water was very cold, and cold water causes adipose serum to be formed in the body. Adipose serum is an oily, waxy substance that is formed by the hydrolysis of triglycerides into glycerol and 3 fatty acids. When adipose serum tissues decompose, it helps prevent the body from fully decomposing. Some bodies have been reported to have been in the water below freezing for several weeks, and those bodies being almost fully intact due to adipose serum. Edward's body was found floating on the surface of the water, which means that the bacteria must have gotten into his stomach, causing gases such as methane, carbon dioxide, and hydrogen sulfide to form. These combination of gases causes your body to float in water. Edward's body was found to have many bite marks around his body. This must be from marine life eating his body before he floated up. Edward's body was also very blistered, and it was a greenish-black color. This is due to the blood flow in the body being cut off and tissues decaying.
We first investigated who would have killed Edward. We asked around the school about any potential motives, and we created a suspect list. On that list was Sara shown. We figured out that the gun angle was 0 degrees by noticing the blood angle and empty bullet casing. The bullet casing fell directly under where we thought the suspect stood. We knew that if blood was dropped from a 90-degree angle, the drop would be a perfect circle. Any angle less than 90 would make the drop more elongated. To figure out the height of the murderer, we must figure out the velocity of the bullet by looking at the gun ballistics. Once we figure out the initial velocity, we can obtain the distance between the suspect and the victim. To work on eliminating suspects, we used Sara's height to figure out if Sara could be the killer. By plugging in her height to an equation, we could figure out the hypothetical time it took for the bullet to leave the gun and hit Edward's head. From that time, we could figure out the velocity of the bullet using the distance. In doing so, we realized the velocity matched the gun ballistics report. Sara was the killer. When we brought Sara into the station for further questioning, she revealed what had happened. Newton's third law is also present in a crime scene. If the gun and shooter are at rest, then the force on the bullet is equal to the force on the gun and shooter. This is due to Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. When the gun is fired, the two objects move away from one another with new velocities. By the law of conservation of momentum states that their momenta must be equal. Gunshot victims frequently fall or collapse when shot. This is a result of the momentum of the bullet pushing them over.
Before we could truly convict Sara as the murderer, we needed more proof, which is where chemistry comes into play. As chemists, we can use different methods to uncover fingerprints and find footprints. We can use certain chemicals like ninhydrin, C9H6O4, to help reveal and collect fingerprints for more evidence. Ninhydrin is dipped or sprayed over a surface which reveals a bluish print. The main drawback with this method is that the reaction is really slow. To speed this reaction up, the location can be heated to over 80 degrees Fahrenheit. It reacts with the natural oils in fingertips to form a compound. Another way to involve chemistry in a crime scene is to use luminol, which is a substance that reacts with human traces that help detectives solve crimes. Luminol is known chemically as C8H7N3O2. Investigators spray luminol on a surface to reveal a light blue outline of traces of blood, feces, urine, and bleach. This works because of a process called chemiluminescence, which is the production of light by a chemical reaction. Two chemicals react to form a high-energy intermediate, which breaks down and releases the blue photos of light.
In conclusion, we found the killer by using physics, biology, and chemistry. Sara is locked up behind bars for a lifetime, and JJ, Chiara, and Alex got paid handsomely for their help in the investigation. Catch us next time on Forensic Files.